Who out of the audience does Erlang for a living? Hands up. That's quite a lot. Who would like to? Okay. Some shy members in the audience tonight. Good. Okay. I basically program Java for a living. So Erlang's a hobby of mine. Something I like to do more at work. But I'm well known in the Erlang community to the extent that I almost talked about Francesco.js today. But he threatened to kill me from New York. So then I thought, maybe I could talk about bit syntax. So I wrote a compiler for bit syntax for Java. It's going to go on GitHub in a few weeks. But I was playing with, I'm actually a chief scientist at a small British startup called Push Technology, but let's forget about work for a while. That's where Java happens. Let's focus on Erlang today. And I decided I'd take two hobbies of mine. One is hacking physical hardware and making things. And the other is Erlang, which is my thinking language, where I do all my research and prototyping in and see what can happen. So in the hardware world, I make things like this. On the left here, we have a drill that broke and two 12-volt car horns. What happens when you put that together? It's a non-lethal human defense system. It's 120 decibels of trigger-happy noise you can put in someone's ear when they come to your door uninvited. Kids love it, and it's great for football matches. On the right is a furry cube that's actually a joystick designed by my children. Most of the hardware I do is designed for my children. And they get me to build things that they design on pieces of paper, so they wanted a cube that made asteroids. So that cube, you plug it into a monitor, and it is a joystick, so it becomes an asteroids game. It had to be furry, that was a strict requirement from my 5-year-old. And I build things like this. There are more of the things I like to build. I start from the low-level electronics and build it all the way up. Rather than buying a Zigbee, I build my own RF protocols because I'm into distributed systems and protocols. That's the area that interests me. Mainly, though, I'm dealing with hardware bugs, which is I plug in the power the wrong way, it blows up, I have to make more orders, my wife gets unhappy. But I decided, why don't I actually take two things I like to do and plug them together? I've never done anything in Erlang. This was yesterday, I hadn't done that yet. This is what I've done last night, but you're seeing it today. That should be awesome. So, I happen to have one of these. These are pretty awesome. Who travels? Quite extensively. Heinz, Chris, you travel a lot. Quite a few well-travelers. This is a 9,000 milliamp hour battery pack. It's also a Wi-Fi access point you can plug a hard drive into, or a flash drive and expose it so that you can share files with people. So it's a lifesaver. You can plug in your phone, you can plug in your laptop, your iPad to get an extra bit of power, and it'll last 4 or 5 phone charges. I'm using it today as kind of like Skynet, so this is going to be the network that the robot is attached to. And on the robot, you can see here, is a little wireless dongle, and this is a repeater, so this is actually connecting to the access point, which is this, and it is getting a feed that I can connect to my laptop as well, so I'm connected. You need a piece of hardware to hack. This is a Robosapiens. I bought it in a car boot sale last weekend for 7 quid. You typically get them for 50 to 100 quid second hand. And I tapped its brain, so I put a wire inside the infrared receiver. Normally you use it with a remote control. And so I hacked into that so I can control it with a RaspberryPi. So we're going to be simulating remote control commands as if infrared from Erlang, which is what happens when you plug all of this stuff together. Okay? So amazingly, to get the full functionality of this robot, you basically just need one Erlang function. One. It's a really simple hack. And this one Erlang function is an if. Robosapiens tell, and you can tell it things to do. Very simple. It's built on top of WiringPi. And then there's a higher level API on top of that, so you don't actually have to type in the byte that tells it what to do. You can just have a high level convenient function that will call down into that tell function. So there's 80 or 100 functions that you can call into the robot to perform. So you could wrap this in Erlang OGP in the web service in whatever you want. It's quite simple. You have it connected up to your Twitter feed. Whenever you receive a tweet, roar. Whenever someone says something nasty about you, make the oops sound. You'll see what I mean in a minute. Okay, so let's have a play. I have a VNC server running on the robot. So I have VNC'd into the robot and I've got a terminal. Okay? It mightn't be Can you see the text sort of in that terminal screen? So this is my terminal shell session on the robot, and I've got an Erlang project here, which, as you can see, is fairly recent, and I'm going to spawn an Erlang shell. Okay, in order to start up the robot itself, there's a startup sequence, kind of like a Formula 1 car. It's not exactly automatically working because it's a hack. It's not supposed to work the way I'm using it. So you take the black wire, you pull the wire apart, that's ground. You turn the robot on. Wait when it does its thing. Then you connect the black wire and everything's fine. Okay, we've got the patch in its brain now, so we can tell the robot what to do. So I'm going to load this Sapiens module. Here we go. Wasn't very exciting.
Yeah, that's very exciting.
And then the fun begins. What would you like to see, Heinz?
I would like to see Wave. It doesn't do that, right?
Doesn't do that. We can make a whistle. We can make him do a karate chop. That's very easy. So hours are fun for all the family. So the reason I build things like this is mainly because I build things with my children. So this, using it with Erlang is fairly new, but it actually makes it quite easy to build interesting little toys with my kids. So that's it for me. With a short talk, as you can see. Woo! Code will be on GitHub soon. Hopefully you'll all start buying Robosapiens and we'll build a swarm. The swarm intelligent out of time questions. Thank you very much.
Yes. Could you control the each motor on its own?
Yes, you can. If you remove the brain, there are 9 motors in there you can control individually. So you can, for example, tilt the body, you can move the arms and the hands individually, you can move the feet.
Is that the plan?
You can walk forward or back.
Do you want to stay with the brain?
I might take the brain out next and use the RaspberryPi as a new brain. So I might do that next. I don't know, the kids haven't told me yet. They tell me what to do, I just obey
Probably
orders.
will have push first.
They'll probably have something up their sleeves for me when I get home.
Was the command set documented anywhere, or did you reverse engineer?
So the hack is well known, so I didn't have to do any reverse engineering. I don't think anyone's done it on the Raspberry Pi, but it was a fairly simple port to port the IR command protocol over to Raspberry Pi. And then it was just a matter of wrapping it in an if and exposing it to a set of Erlang modules which have most of the well-known functions. And there are about 80 functions or 60 functions you can call into, which are moving the arm, moving the legs, walking forward and backwards, and fairly special sequences like karate chops, fighting sequences, roaring, whistling, stuff like that. So it's fairly controllable. There's also these buttons, touch sensors. So when it bumps into something, you can get a signal from that as well. So there are other aspects of the robot you can actually hack into. You can hack into the speaker to speak your own text through it as well, which is somewhere on my to-do list. Maybe tomorrow.
You mentioned you probably build these with your kids.
Yeah.
You actually write the code with the kids, so they get involved in that.
I typically expose them to a visual programming language called Scratch. So Scratch, they plug and play visual elements together rather than programming Erlang. In fact, my 7-year-old is learning Python because it's a very strict language, it's a very good language for kids to learn, and it's a very good reading material on how to teach kids Python programming. So my 7-year-old is learning Python. My other, 2 of my other kids are learning Scratch. So every kid is different. Maybe one of them will be an Erlang program. I don't know. We'll see. Good question. Any other questions? Awesome. Thank you very much.
And to start, I want to give a little background. I personally love SmartOS as a hypervisor. Basically, the whole thing started off when I had one server on the internet, the whole of one server, and I was sharing it with 2 other people and wanted to virtualize. So basically, the decision was which kind of virtualization to use. VMware had this sucky limitation on memory. Xen had some horrible things with user management. Linux and KVM, I just wasn't comfortable with that. And I stumbled about SmartOS. And SmartOS has some great features. I will read them since it's not very well readable there. One, there are zones, which is a Solaris virtualization method, which pretty much is bare metal virtualization, so it doesn't spawn another kernel, but you have the whole virtualized set of applications in your zone. And there's dtrace, which is a great tool for observability and taking a look into your application, measuring, getting some idea of what is going on. There's ZFS, which is, in my opinion, probably the best file system you can get at the moment. And there's Crossbow, which is a very cool way of network virtualization within one operating system. So you can make bridges and little switches in there. And then you can go and make flows with like saying, okay, we have 10% package loss on this connection, and you can really go nuts on that and add stuff and test and play around. And then there's KVM, which is, the Linux people already know this for years, but in a Solaris environment, this is really something new and great, because you don't only have these zones, which are very powerful if you can run your applications in Solaris, but you also have KVM, so full virtualization, and can pretty much run everything there. You know, the big but, there are some things SmartOS doesn't do very well. It is a single user system, so you have the root user and you have the root user, that's it. And you have to share this with your other people running stuff on there to create VMs, to modify VMs, start and stop them, which is just doesn't feel right giving multiple people root access. I think everyone can sympathize with that. You only can have one system. So, okay, in my case, it's not a big deal. I can run everything on my one system, but by now I have 3 systems, so I probably would want to have some central management. There's nothing like this in SmartOS. And you really need to expose access to this global zone, which is to the hypervisor, to the internet. And that is also not a very nice thing to have. So there are some great things, and I really want this green box. I really want everything in there, because it's, for a hypervisor, in my opinion, the best you can get right now. But I'm very upset about the things in the red box, because honestly, all of them are not very nice. There's one solution called Smart Data Center from Joyent, the people making SmartOS, but this again costs money. And since I'm doing the server, or did the server, on a purely for fun basis, I can't pay, I don't know what the prices are, probably a couple of $1,000 I would have to pay per year to get the server running, and that's not an option for me. So, that is pretty sad. Yes, please.
Can you explain that? Are there fundamental reasons for those limitations?
It's just the way the system is built. Joyent releases SmartOS as a basic version of their hypervisor, and it's a single system solution. So the default solution is to have one root user there which can do stuff, and there is no communication between systems. If you have 2 of them, you will have to access the global zone to create VMs or work with virtual machines. So that's pretty much, it doesn't have to be a limitation, and we'll come to this in a minute, but from the bare metal SmartOS system, this is what you're stuck with.
But it's a Solaris OS, right?
It's a Solaris OS that is built back. There is a very focused operating system, so it's not a general purpose system. It doesn't have its own disk partition. It boots from USB stick. There's no consistent storage of data on it, so all these things go icky if you add users that are away on the next boot and so on. Okay, so basically that's very sad, and that's what I was looking like when I found SmartOS, and then I found out I can't do what I want with it. But there's one thing: if there's something you want and there's no solution, but you really want it, you always have to do it yourself. So I sat down and figured, okay, I want this, and I want it really bad, and I started building something. The first iteration was based on ClojureScript in a Node.js, and it sucked a lot. The second iteration was some Erlang, and got a lot better. and the third iteration got clustering in there, and the fourth iteration rewrote all that. So it was a hard road to go to where it is right now. But basically it's ended up, if you want something, do it. So what we have now, we have a central user management, we have a SSH key management, which means you can, from the interface, grant users access to virtual machines, and they upload their keys, and the moment you click, they have access to the machine. You have a very fine-grained permission control for your users, so you can give them access to start VMs, but not stop them. It's like someone who's doing operations work and maintenance. You want them to be able to start machines that crashed, but don't want them to stop the customer machines. And you can go really fine-grained in this because it's this nice structure. You have a system of roles or groups, however you want to call this, so delegation of permissions to multiple users. For the virtual machines, you can do all the stuff. You can create them, you can edit them, you can destroy them, you can start, stop them. You have in a web UI, you have a no VNC server, which is like a web console. You can go on the graphical interface for KVM machines. And you have a console for the Laris machines, which basically gives you access to the serial console of this. You have an SSH key management with access features for the zones. You can do snapshots of machines, so roll them back and forth. You get some metrics for your virtual machines all from the user interface. You have a smart algorithm to pick the best hypervisor. If you have multiple ones, you can set up roles which look for certain characteristics. You can rank them by points and then go in the end and pick the best one. So customize the algorithm, because I guess different people have different preferences. One said, okay, I want everything on the one type, then on the next, and then on the next, and the next person, okay, half goes on this and half goes on here. You have some metrics for the hypervisors, which like show you the CPU usage on the hypervisor level. And you get warnings when your storage pools degrade, you have a RAID failure. There's a big red icon I stole from Rear Control. Actually, I copied it, it is under open source license, I even asked. And a big green icon, so you go on the start page and you see everything is fine, or oh no, I should do something. There's a lot of cool stuff, like a distributed dtrace. You can run a dtrace script over multiple physical hosts, collects the data, aggregates them, displays them. You have a virtualization for this dtrace. You don't get raw data, but you have like heat maps you get in the UI from this distributed thing, and you can go over a bracket in this heat map and see, hey, okay, this process is taking a long time to write, or a long time to read, or does a lot of syscalls. The whole thing is built on top of React Core. I guess most of you know what this is. It's a framework, Basher released. It's the same framework React, the database is built on, which is pretty much an abstraction of distribution. So the system is built for failure. So one host can't go down and the system is still running on the other hosts and doing all the work. And it's using CRDTs, which is a very nice kind of data type to store some of the data, soon all of the data, which has very nice characteristics on read repairs in the database and on how they merge together when there's a difference. So even in the case of a real network partitioning and someone's adding here and someone's adding here, they merge together quite nicely and quite expectedly.
What does CRDT stand for?
CRDT stands for Concurrent Distributed Data Types, but the C is arguable. It's also standing for converging, for coconut, and something else I forgot. Basically, you can use everything for C. The point is that data types which are built to be edited in two positions at two areas at once and merge together, and you have no data loss during the merge. So it's always come out in a kind of making sense way. So it's not like, I don't know, you're using React?
I know.
Okay. So it's not like a last write brings, so you don't get the latest data back, but you get a sensible merge of all your data back when after a partition data is merged together, which is a very nice feature. So it limits the probability of data loss in the case of network failure or node failure. basically this is all to build a system that has a very high uptime. And probably the best for you guys is it's 100% open source, everything is on GitHub. It's 100% free, you can use it. There's no limitations, released under the CDDL, so a kind of permissive license. Yeah, so that's the cool stuff. And in the end, that's really something that made me happy. So I'm personally using it like 9 months now on my server. I know other people are using it. There are some commercial people who are using it by now. Some universities are looking into it for departmental, internal stuff. There's some interesting article about FiFo and SmartOS in general on the internet you should read up. Okay, that's general, that's FiFo, that's what I'm talking about. So I want to talk a bit about what I've learned in this year and 3 months by now. Because there are some interesting things. For once I found out that building one big application, even in Erlang, is not a good idea. You end up with gazillions of lines of codes of logic in one application. It's much better to split it out, have some network interface between your applications, like building another layer of OTP and servers on top of applications. Don't copy just OTP and servers, of course, and you can use one. But think about, like, the user management is one application which is entirely standalone. You can use it in other projects if you like. You don't have to use the rest. The service for doing asynchronous messaging between user interface and the backends is the own server, which you can use on your own. The central system doing the logic is one server. The API server, the web server, is a single server, so you can have all the small applications work on their own and you don't have one big thing. Make a good interface. It's important. I use Wrench, for example, and TCP and BERT for serialization. And then abstract the interface into a library. So you have a library and the application. For example, the user management application is called Snarl, and there's a libsnarl. So if you want to use this same logic of user management, FiFo uses in your application, you put in the libsnarl, can set up a Snarl server somewhere, and are happy with it. It also makes building this thing for me a lot easier, because I can just fix one application if something's broken, I don't have to do all the big thing. The MDNS trick, yes?
When you say application, you mean separate releases?
Yes, separate releases, really. Really own applications, own packages if you release via package system, which you can separate. Really own GitHub repositories, no code sharing, other libraries, of course. The MDNS trick, I found it very nice. Each server is broadcasting its presence over MDNS. There's a library, MDNS server library I wrote, or I copied half and wrote half, which does broadcasting and opens the TCP socket and does some handling about when data comes in. And the nice thing is it's a little bit like OTP over TCP. Because if the server goes down, since the lead times for MDNS are very short and the client libraries are smart about sorting out servers that have failures, the server just disappears and it can use another server. Then if it comes back, it does the MDNS announcing again and it comes up again. So there's a nice way of automatically handling network failure between different machines or server failure, given you have more than one system, of course. If you have one system, that doesn't save you. Yeah, that's the MDNS thing. And it's really nice. Also does a little load balancing, because you can have multiple servers in, they all MDNS broadcast. The client library is also listening to MDNS, automatically propagates pools of servers. They are interchanged and used, and so you don't get a really measured load balancing, but you get a round-robin load balancing, which is quite nice. A big thing you shouldn't do, it's one big mistake I made. Don't model for representation. There's a typo in there. It's called JSON. The web interface, the web API uses is REST-based JSON, like 90% of everything today. And I had the great idea that if I store the data all the way from the top to the bottom in JSON, I have a very nice time serializing it in the end. Which is true, the web interface is really easy on this one. But it makes the logic a lot more complicated. Please don't do the mistake I did. I am now rewriting all the backend code to use records again, because it's just easier to handle and nicer. It is a horrible mess if you do it. JSON is nice and good for transportation, but don't store your data in it. Use something sensible. Records, you can version records, you can easily access stuff in there. You don't get suddenly, because you have a typo somewhere, you get passvd and password, because in one place you think, oh, I called it passvd, and then the other, wd, sorry, and then the other you think, oh, I wrote it out, I called it password. All those things don't happen if you use records, and it's easier checkable, and you can use DLIs and everything. Please don't model for representation. Yeah, and Erlang. There are very, very good things about Erlang. There's fault tolerance, there's self-healing, there's a distributed architecture, and you know, I am preaching to the choir here, that's why I'm not talking about this part of good Erlang. I want to talk about the mindset, which is the best thing I took from Erlang. When I look at Erlang, as a person, I think it's like an English gentleman. You know, I didn't pick this because I'm here. I actually think it's a very nice, analogy. And other languages, they are like this kids, like running around crazy, yeah, kids. And if they have a problem, they are going, whoa, problem, and all excited and run around and start doing stuff and hacking into their computers and are unorganized and are screaming around. And you look at the guy, and you probably can divine what I'm meaning. When you tackle a program in Erlang, it's kind of different. At least that's how I perceive the culture and the mindset of the community. The Erlang programmer is like the English gentleman. He takes his 3 o'clock tea or 4 o'clock tea, I'm not sure when you're drinking tea here in the UK, and sits down with some scones and thinks about it. Then in the evening he goes to the gentleman's club, chats with his pals about the problem, has a good night's sleep, gets up, some sausages, some eggs, and somewhere in the afternoon he sits down and has all this problem sorted out and laid out in front of him, and he goes and writes his 5 lines of codes, is happy, and goes off to wave to Queen Mom. And the problem works. No, the solution works. And that's really something which I find very special about Erlang, which is, in my eyes, the best thing, because everything else you can easily copy in pretty much every language. But this mindset of think first, do later, instead of just, oh come, let's do something, is something I perceive as very special and very unique to Erlang. And probably the best thing about the language or the community as a whole. There are some bad things in Erlang too. The unit process interaction sucks, to say it quite directly. It's very horrible and very problematic. You have to use standard in and standard out, or NIFs if you can write your own code. The moment the program doesn't behave exactly as Erlang wants to, which means it talks over standard in and standard out, there's no output after one of them is closed, and both of them are closed means the program closes. If this is all the case, everything is fine. But if you have a program, for example, that takes the input, waits for standard in to close, does the processing, and gets the output, there's no clean way to do this. You can write a hacker, wrapper, ugly script, but then you're back to this guy here. If your application expects one of them, it doesn't closes when standard in, standard out closes, the thing stays alive forever, because Erlang doesn't terminate it even if the Erlang VM terminates. It just stays there. Which is why one of my applications actually has a pkill -9 somewhere in the stop script, so the application stops properly. I could try to fix the application, the Unix application, but I personally think that's not a very good behavior to work from the Erlang side. There are not so many libraries. Sometimes you come along something and there just isn't the library for it. Which in languages which are more prominent, you probably get 5. Given you have still to choose between 5 bad libraries probably, but there are some missing things. And you will end up writing your own libraries for stuff you like. Which again can be good since you have control over them. And one thing I always get angry when I do releases is that people don't version their libraries. They put them on GitHub and use a master branch and nothing else. There are no tags for versions, there are no branches for versions, so you have to rely either on a icky, how's it called, hash, or just hope that they don't break the master branch, which I can tell you, you shouldn't, because it will break. I've run into this a few times. The side of my experience so far with Erlang, which I wasn't so happy with. No, that's the wrong key. Okay, that all said, I want to give you a look in one of those applications. We'll talk about Snarl, the write management, because it's, in my eye, the most interesting separated application, because you can, excuse me, really use a standalone. It has a great value for other users, because write management is a problem that always surfaces somewhere, and there are some very interesting technology choices in there. So basically what Snarl does, it's write management, it has users, it has groups or roles, it has organizations, which is a mechanism to automatically distribute or create new permissions on certain events. For example, when you create a VM, you can create permissions for this VM in certain groups. Like you have an admin group who can start, stop, and reboot. You have a user group who can just start and view. And this can be over organizations, and the roles in organizations can be automatically created with new permissions. It's totally standalone, it doesn't depend on any other component in FIFO, which means it's really reusable for everyone. And there's a nice client library who does all the MVNS stuff for you. So you don't have to worry, put in the client library, do the calls, and you can use it pretty much. So there are those 3 things. There's the user, there, the user, and the organization, and back here the group. So basically, while the relation between user and group is pretty much right delegation. It's called group for historical reasons. It behaves more like a role. Sorry for the confusion, but I don't want to go through my code and change every group into a role, because I think I will miss 1 or 2. Don't laugh. So the user has a list of groups to which he belongs, or she belongs, and when the Snarl gets queried, if a user has a certain permission, it first looks if the user has it itself, or if one of the group has a permission. The relation between user and organization is a user does things in the name of the organization. So there are actions which trigger an event in the organization. In FIFO's example, that would be the creation of a VM. The organization, again, has certain rules to create permissions in groups after an event. So it's like a full circle, you go there, and the organization doesn't hold any permissions themselves. There's entirely opaque to permissions, they don't know what they are. The user is just using organizations as I'm doing it in their name, and most of the rules and most of the permissions are stored in the groups. So that's how the data is arranged in FIFO. And this whole thing is built on top of React core. So you have this nice React ring. I stole it from Dash the ring with permission. I asked them. They actually sent me one. I think they get money for the ring when they see it in presentations. Each user lives on 3 nodes, each organization lives on 3 nodes, is distributed. If one node fails, the user is still there on 2 other nodes and things can happen. Since everything is stored in CRDTs, even if you do something and you have an outdated user and it comes back, they merge together. There is a garbage collection algorithm to clean up the CRDTs. I don't know, probably if you're into CRDTs that will be exciting. If not, it sounds very mundane. So you have very high fault tolerance, you have a very high availability, and you have something that's called eventual consistency on your data. Which I decided is good enough for me. You might see it differently. So, the user or the group or the organization is built on top of this CRDT. So you have last write win registers for things like the username or the password hash, which pretty much means if you have outdated password here and a password here, only the one that is newer is kept, which is a CRDT, but it's a very sucky one, but good enough for things like username or password. Since it's a behavior you expect. If you have two different passwords, you want the newest one to be the valid one. The things like permissions or groups and organizations are stored in something that's called an observe remove set, which is a set that works the way if you have an addition here and an addition here, they go together. If you have a deletion here, only things that were in here gets deleted. If there's addition here, it stays in there. So it's a very much, it behaves pretty much as you expect for a set where you can add and remove things and you merge them together, which is creating a lot of garbage since you have to keep a lot of information. That's why there's a nice garbage collection algorithm in there, which is very exciting and keeps the memory low. It also fixes outdated data, a bit like React's active anti-entropy algorithm, just less smart and more just go over all data. Okay, that's how the data is stored, which I personally find a very exciting thing. The CRDTs are great. Then you have this MDNS and Ranch server on the server side. Yeah. So it's, once the server comes up, it starts broadcasting, hey, I'm here, this is my domain, this is my IP, this is my port, I'm a Snarl server, you can use me. And on the client side, there is a pooler, which is one of the pooling libraries for Erlang, GenTCP to create the connection, and the MDNS listener, which says, oh, I found some Snarl, and goes propagate the pools with TCP connections, so the client can start using them. If one fails, it gets removed from the pool. The default timeout is set to 60 seconds, so even if you don't have a failed communication after 60 seconds of a dead server, it gets removed automatically. Other than that, it gets bad points for every time it misbehaves. If it reaches a certain threshold, it's removed and only added again when it's newly discovered. So that's the client side. Yeah, and that's Snarl. Any questions? Good. And I did a good or a very bad job. Okay.
What did you use for testing? What was the approach for that?
I use for testing proper in some places, which is a bit tricky since it's GPL'd. But the proper guys are very nice when you ask them, allow you to use it for other open source licenses. EUnit, of course, for some unit tests, and React tests for integration tests of a whole system.
So no common tests?
No.
And were you actually starting this distributed system and trying to... How does this React tests, integration test work?
What React test works the following way. It was, of course, built for React in the first place. It creates 4 instances of your application, and from React test you can manipulate them. So you can join them, you can take nodes down and up, you can do API calls.
So it's creating a distributed system.
Exactly, it's creating the whole thing, and you can do It can check everything with it. Node failure, recovery, which is very, very nice for distributed systems.
But did you use React Test because you were using React Core, or you can use it independently of the distribution algorithms?
Very much easier to use if you use React Core.
Okay.
Actually, I had to fork it and do some manipulation because the React Test from Basho is really only working with React. So there's some ripping out of React-specific bits happening. But a lot of the logic could apply to general Erlang distributed applications.
Okay.
So if you rip out the remaining React core bits, you could have a system which does node start, node stop, communicate with a node, do remote function calls on the node, independent from React core.
Thank you.
I was wondering how this approach compares to the approach for managing hypervisors and that kind of thing. Do you use the same approach building that data structure on top of React Core?
The hypervisors are a little separate because it's a bit tricky. In SmartOS there's a thing called global zone, which is a bare metal hypervisor. And the common understanding is that it's very bad to run anything there. Since it's running as root, it's in the core system, you don't want it. So there's only a very small service in the global zone, which pretty much is only executing commands there, that connects to Sniffle, which is another component, and gets the commands over this. So there's no distribution going on the hypervisor level.
I think what I mean is, I think I probably mean zones. So you presumably have some UI to create, or some API to create
Yes.
zones and associate them with users or organizations. Yeah. Does that use the same approach in terms of?
Yes, that uses the same distribution approach, minus the RDTs at the moment, because it's all still storing it in JSON. I want to go away from this, but it's a big task to remodel all your backend data.
So does that store it in JSON in process, or what's
No, it stores this in a JSX-like representation. So Erlang terms with lists for arrays and lists of tuples for objects. It was a dumb idea, to be honest. No, but it's distributed over the same kind of framework on top of React Core and for the different kinds of datas and different bnodes.
And do you think kind of an eventually consistent approach is appropriate there?
Yes, because with one exception, which is IP ranges, since that you eventually get different IPs is not good enough. Currently it's handling it pretty well, but it's one of the big areas where there's an exclamation mark where I need to do some work on. Everything else, I'm very certain that a eventual consistent approach is good enough. Since when you create a VM, it gets merged, it's okay. If you create a new dtrace script, it's okay. There's no harm in eventual consistency. There's more harm in downtime. At least that's how I think,
Sure.
which might be wrong. Okay, oh yeah.
You said that Snarl's completely separate and reusable.
Yeah.
So what kind of uses would you envisage? Is it a kind of, would it be like a general purpose user authentication?
You pretty much can do everything with it where you have users and roles. You can ignore the organizations if you don't want them. You can also ignore the groups or roles if you don't want them. And have a certain set of permissions. Permissions are very simple. They are a list of binaries, and they match if they match, and they don't match if they don't match, with two exceptions. The binary underscore means here can be everything in a permission. So for example, there could be a permission virtual machine underscore start, which would mean the user can start every virtual machine. And three dots, so dot dot dot, which would mean everything from here on. So VM ... would mean everything that starts with VM is matched. And then you can query the service if a user has permissions. You have an authentication with tokens. You get a token back, which you can use as a session token for a web application. And the token is mapped to the user, which is versatile. So, sorry, I ignore this word. I'm not sure if it's the right one. So it's memory only, while the other stuff goes on the back end. So tokens are on the data disk. So the tokens are pretty fast. Yeah, so everything that has users and permissions could use Snarl. If you're happy with eventual consistency and if you have some kind of permissions. You could ignore the whole matching stuff and just make one binary permissions, for example, which also would work.
Eventuals, it's not like next week, is it? Eventual is quite soon.
Eventual is pretty much right now, unless you have network failure. So eventual consistency here works the way that if all nodes are there, it's pretty much consistent. Eventual consistency only means that if you have like a network partitioning, you still can work on both sides and then they get inconsistent. But when they go together, back together, which eventually will happen, they are eventually consistent again. But again, it's a thing. If you're happy with it, you're happy with it. If not, you're not. It depends really on your approach on the topic and on what your application needs. For FIFO, I made the decision that availability is more important than consistency. Mostly because I find it kind of icky that cloud providers go and tell you, yes, our cloud has 99% uptime, so your application, or 99.999 uptime, and the application can have 99.999% uptime, but our API doesn't. That doesn't feel right to me. So I think if I'm going to sell someone a high uptime, I will have to prove it with my own stuff that it works. And for example, I don't think Amazon's API has the same uptime as their cloud. The API is down quite often when I'm not mistaken. Which is partially probably because they have it consistent. So I'd say. Okay. So you're all happy. I hope you enjoyed it. And thank you a lot for coming.